कर, but this small piece of implant costs around 1 lakh plus. Apart from the primary cup, so this costs 1.25. Solution is there, but it's not affordable, so not much people can use it. So what we have done in CSIO, we have designed this kind of implant indigenously, filed patents for that. So different kind of implant for different kind of situations are there. So we have transferred this technology to industry, and we are expecting the 1 lakh, the price tag will reduce to 60 or 70,000 rupees. Still, we don't say it is cheaper, but it is going to more affordable to a greater number of population. So the usage will increase, and the beauty is, if this is implanted, there's no need of retrieving it. It will last lifelong. So this is the one of the augment surgery that we did around. This was around 2018. So there were very less bone stock was available to preserve the bone stock. We designed a special augment for it. This was implanted. So this is another implant for which we hold a patent. This is not available in India. So होता क्या है, डिजिटल avascular necrosis फीमर हेड, यहाँ का फीमर हेड है, उसमें ब्लड सप्लाई कम हो गया है. अब सॉल्यूशन क्या है कि इफ इट्स वेरी इनिशियल स्टेजेस, द डॉक्टर विल ड्रिल वेरी माइन्यूट होल्स इन योर बॉडी, ट्राई टू रिस्टोर द ब्लड सप्लाई. अगर उससे नहीं हुआ, देन सॉल्यूशन करंटली अवेलेबल इज स्ट्रेट अवे गो फॉर हिप रिप्लेसमेंट. और हिप रिप्लेसमेंट का इशू क्या है, इफ यूर यंगर पेशेंट, सपोज 40 में आपको हो गया, तो बाय द टाइम यू टर्न 55 or 60, you will again go for one more replacement, and by the time you reach 75, again one more replacement, and with every revision surgery the bone stock decreases. अगर बोन जिसमें फिट होना डिक्रीज हो जाएगा, तो इम्प्लांट बिकम मच मोर कॉम्प्लेक्स. सो द ब्यूटी ऑफ दिस इम्प्लांट इज, इफ इट इज यूज्ड बिटवीन stage 2 of necrosis, you don't require any hip replacement. Your original bone will restore the blood supply and can last life. No need of going for hip replacement. So this is not a similar kind of implant is available in US and Germany, but not in India. So what we did is we improved that implant with 3D printing. So the implant designed by us had a cannulation provision. Cannulation is क्या होता है कि implant का छोटा सा होल है, उसके नीडल पास कर जाते हैं और आप गाइडेड ग्रोथ करते हो उससे. अब पीछे ये होल दिख रहे हैं, इससे क्या होता है, जब हमारा स्टेम सेल्स होता है, वी कैन इनपुट स्टेम सेल, सो बोन ग्रोथ रेट इज ग्रोज एट मच हायर रेट. तो रिस्टोरेशन जो ब्लड सप्लाई का बहुत हाई रेट पे होता है. और दिस वाज सर्जरी डन बाय वन ऑफ आवर डॉक्टर्स, एंड वी डिड दिस केस, वी हैड पेटेंट फॉर दिस. और ये कोविड जिनको हुआ था, कोरोना, उनके केसेस में बहुत ज़्यादा केसेस एकदम से बढ़ गए थे, विच वर पर्सन अफेक्टेड बाय कोविड. सो we have transferred this technology to Cipla Medtech. अच्छा, ये एक और इम्प्लांट है, दिस ऑल्सो नॉट अवेलेबल इन इंडिया. अभी हुआ क्या, आपका जो एसेटेबुलम है, जो यहाँ पे हमारा होता है ऊपर का रीजन, इससे बोन बहुत कम है बिकॉज ऑफ कैंसर और ट्रॉमा, कुछ भी हुआ. तो सोल्यूशन क्या है आपके पास, तो आप नॉर्मली कस्टमाइज इम्प्लांट पे जाओगे, विच अगेन वेरी एक्सपेंसिव, नॉट एवरीबडी कैन अफोर्ड इट, एंड इट टेक्स ए lead time is around 15 to 20 days of time, and not everyone. So what we did is, so because a bone here is not available, but here it is available, so what we did is we put a cone inside along with the hip cup. उससे क्या होगा, we can have go deep inside our pelvic region, और फिक्सेशन जो उसको बोन ग्रोथ वहां से मिल जाएगा. यहाँ पे बोन कम है लेकिन ऊपर तो है ना, it becomes a ready-made solution. We can make in multiple sizes अवेलेबल रेडीमेड. आपने आज ऑर्डर दिया, कल आपको अवेलेबल है, एंड अवेलेबल एट कंपेरेटिवली मच लेसर कॉस्ट. अब स्पाइनल इम्प्लांट्स, जब आपने सुना होगा कि L4 L5 में दर्द हो रहा है, आजकल की हमारी जनरेशन बहुत कॉमन है, बिकॉज वी आर यूज टू सिटिंग जॉब्स, कंप्यूटर आगे बैठे रहते हैं, वी डोंट डू एनी फिजिकल एक्सरसाइजेस, पेन शुरू होता है पीछे, या जो लोग मोबाइल यूज़ करते हैं ना ऐसे. तो अभी थोड़े दिन पहले एक आर्टिकल टाइम्स ऑफ इंडिया में, बाय यूजिंग मोबाइल लाइक दिस वी पुट 20 kg ऑफ वेट ऑन आवर सर्वाइकल स्पाइन. तो होगा क्या, इट विल स्टार्ट पेनिंग. इनिशियली पेन हुआ, यू गो टू अ डॉक्टर और एन फिजियोथेरेपिस्ट, विल से यही एक्सरसाइज करो, उसे ठीक नहीं हुआ, यू गो टू अ योगा टीचर, 6 महीने लगा दिए, सिर्फ ठीक नहीं हुआ, यू गो टू एक्यूप्रेशर. जब सब ट्राई कर लिया, तो आगे वापस ऑर्थोपेडिशियन न्यूरोसर्जन के पास, वो ही विल से योर डिस्क डिजेनरेटिव, यू नीड टू गो फॉर इम्प्लांटेशन. अब आपको स्पाइन इम्प्लांट होगा. अब स्पाइनल इम्प्लांट का क्या होता है कि कहाँ से हम इंसर्ट कर रहे हैं. इफ़ यू इंसर्टिंग फ्रंट, इट इज कॉल्ड एलिफ, एंटीरियर लुम्बर इंटर बॉडी फ्यूजन. पीछे से इंसर्ट करते हैं तो इट इज पोस्टल लुम्बर इंटर बॉडी फ्यूजन, पीलिफ. और साइड से करते हैं टीलिफ, ट्रांसफॉर्मर लुम्बर इंटर बॉडी फ्यूजन. ये भी सॉलिड आते हैं. अभी स्पाइन का क्या, इम्प्लांट का क्या दिक्कत क्या है, देयर लॉट ऑफ नर्व्स गोइंग बिसाइड. जो नर्व स्पाइनल कॉर्ड होता है उसमें बहुत सारे नर्व जा रही होते हैं. तो इफ डजंट फ्यूज, तो नोबडी वांट्स टू रिविजन सर्जरी इन स्पाइन. कि स्पाइन इज ऑलवेज वेरी कॉम्प्लिकेटेड, सारी नर्व जा रहा है वहाँ से, तो एक नर्व छिड़ गया, छिड़ा यहाँ पे है, और पेन, पैर यहाँ से काम करना बंद कर गया. शाटिका सुना होगा बहुत सारे लोगों ने. सो होता क्या, आपके स्पाइन की नर्व यहाँ पिंच हो रही होती है, दर्द आपको यहाँ पे होता है. तो देर आर लॉट ऑफ, पूरा ब्रेन से कम्युनिकेशन इज थ्रू स्पाइन ओनली है. तो अब होता क्या, आपका इम्प्लांट जब लगा तो आपने इन दो L4 L5 यू पुट अ स्पाइनल इम्प्लांट. अभी सॉलिड इम्प्लांट है तो व्हाट यू डू इज यू टेक, अब इसमें 6 देख रहे हो, इसमें क्या होता है, आइदर यू पुट, आप यहाँ से ग्राफ निकाल लोगे एक्स्ट्रा हमारी रिब से, वी कैन सर्वाइव विदाउट रिब्स, या आप आर्टिफिशियल सिंथेटिक बोन ग्राफ डाल दोगे उसमें और फिक्स कर दोगे. आपके दो वर्टिब्रा के बीच में करके डाल दिया, दो वर्टिब्रा फ्यूज होकर सिंगल बन जाती हैं. और इफ इट्स फ्यूज्ड, इज वर्किंग फाइन, इज वेरी गुड. अगर फ्यूज नहीं हुआ तो क्या होता है, द इम्प्लांट शिफ्ट टू माइग्रेशन बोलते हैं इसमें. तो माइग्रेशन की वजह से वी नीड टू डू अ रिविजन सर्जरी. So, but if we use this kind of lattice implant, the advantage is load transfer top to bottom of the spine is better, and bone can ingrow in between. Bone ingrow करने से there will no chance of migration. So after revision surgery, avoiding revision surgeries, we are promoting fusion. So this kind of implants can be designed using 3D printing. So now we come to customized implants. So अभी तक आपने देखा जो भी implants थे, so they can be used or available in various sizes or shapes. So fulfill most of the criteria or the requirement. But what happens if none of those kind of implants or any implant available in the market fulfills the requirement? So what is the solution? So we can, nowadays the technology is so much matured, we can design special implant for a particular patient. This is all customized or patient specific implant. So we did our first case of customized implant. We were first in India to do the customized implant zygoma. आपने ब्लैक फंगस सुना होगा, कोरोना के टाइम में बहुत डी फेमस वर्ड था, नॉट कांट से फेमस. तो टेक्निकली म्यूक्रोमाइक्रोसिस. तो वी डिड अ फर्स्ट म्यूक्रोमाइक्रोसिस अ ब्लैक फिंगर के 2016 वेव प्रियर टू कोरोना. इसमें होता क्या, आपका बोन यहाँ से इन्फेक्ट होना शुरू होता है. अब यहाँ का देर इज नो रेडीमेड इम्प्लांट अवेलेबल. तो डॉक्टर विल डू, डॉक्टर विल टेक अ फिबुला, जैसे एक्स्ट्रा बोन नी के साथ में होता है ना, ध्यान से अब जाके अनाट में पढ़ना, देर टू बोन्स, नी के साथ में फिबुला. उसको निकालने से यू कैन सर्वाइव. यू वॉन्ट एबल टू रन बट यू कैन एबल टू वॉक, सब चलेगा. ठीक है. डॉक्टर विल टेक दिस फिबुला आउट एंड मेक इम्प्लांट, कट करके इधर फिक्स कर देगा एंड विल सर्व द पर्पस. तो अब बट उससे देर लुक्स नहीं आता है, काम चलाओ, इट्स लाइक काम चलाओ सोल्यूशन. बट नाउ वी हैव टेक्नोलॉजीज, तो हम स्पेशल इम्प्लांट डिजाइन कर सकते हैं. व्हाट वी डिड इज वी हैड अ सॉफ्टवेयर कॉल्ड मिमिक्स. सो हमने उसमें वी टुक सीटी स्कैन ऑफ द पेशेंट, converted the scan data into 3D model and designed the implant over the patient's scan data and implanted into the patient. And this was in 2016. The images of two months, 6 months. And if someone is interested, this was the implant, and I was there present in that surgery. So it is, insertion is also a complicated thing. So it is hand. हाँ दोबारा चलाना. So this is another example of customized implant for zygoma. Here the disease tumor, cancer. उधर क्या था? Black fungus. Here it is cancer. So similar kind of implant, but different kind of disease can be there. But if you look at carefully, look at image of the patient here, and look at image of the patient here. So what you find is there's small skewness in this eye. थोड़ा आँख खिंचा हुआ है. Why? So this was the first case in India, and the doctor's first case, also first case. So pretty much we did all the FA analysis. We were pretty much sure 1.25 mm thickness is good enough for this kind of implant. But the doctor wanted to very much sure, so he asked us to design 1.5 mm. So because he is the one who is going to perform the surgery, we agreed for 1.5 mm. So 0.25 mm of thickness added has a drastic change in results. So in this, you cannot find out whether she is having any kind of implant or not. In the earlier one, the skewness in eye was there. So whenever you work in maxillofacial region, so tolerances are very much tight. So yeah, you have to take care of those things. So now we come to this again, a case of customized implant. So how many of you drive two-wheelers, scooter, motorcycle? कोई भी नहीं, सब चलाते. Do you wear helmets? Yeah. Some of you may not be wearing helmet. जहाँ पे कम्बल चलाने का डर नहीं होता तो लोग नहीं लगाते. So it's a human tendency. Okay. So this was again a patient. So he was a telecom operator, not wearing any helmet, had an accident. So what the situations got into this one. You can see all his bone fragments are there. So अब trauma के केस में क्या, accident केस में क्या होता है? So the first priority is rushed to hospital PGI. The first priority is to save his life. तो उस वक्त जो भी अवेलेबल होता है, डॉक्टर विल ट्राई टू परफॉर्म द सर्जरी विद व्हाटएवर इज अवेलेबल. बट हुआ क्या, इसका ऑर्बिटल फ्लोर जिस पर आँख रखा जाता है ना, वो डैमेज. सो एक आँख ऊपर एक आँख नीचे था और यहाँ से पूरा डिफॉर्म हो गया. बट द सर्जरी वाज परफॉर्म आफ्टर द एक्सीडेंट. सो इट टुक 6 months टू रिकवर इट. अब उस रीजन में क्या हुआ, टाइम फ्रेम में हिज बोन वॉज मालयूनाइटेड. यू कैन सी स्मॉल क्रैक ओवर हियर. तो जो हिस्सा ऐसे होने तो ऐसे जुड़ गया. अब हमको उसको वी नीड टू कंसिडर ऑर्बिटल फ्लोर पर आग रखा जाना है, बट उसका पोजीशन ठीक नहीं हो सकता. हम इसको ठीक नहीं करेंगे तो, और ये ठीक नहीं होगा तो पीछे देयर ऑप्टिक नर्व्स आर देयर, टच हो गया तो ही कुड गो ब्लाइंड. सो व्हाट वी डिड इज वी डिजाइनेड 2-piece kind of implant. First implant for correction this zygoma to correct black. Then after alignment we'll put a orbital fluid implant for its eye to rest. तो ये हमने इम्प्लांट बनाया और दिस इज CT image of the patient. And this case was came into Ernest Wang case studies of the year 2019 here. Now another case study. अब इसमें क्या हुआ, patient had cancer of the mandible, lower jaw बोलते हैं ना, जबड़ा, उसका हुआ. तो doctor wanted a tray kind of implant. इसमें what was his idea, he will take the fibula out from the bone, put it inside this tray kind of implant. After 2 years he will remove this metal plate and by the time his bone has ingrown in between, उस पे वो काम चल जाएगा. ठीक है. We designed this implant, printed, given to the patient, and this was after 1 month. If you look at this implant, same lower mandible, नीचे का ही है ना cancer, but the implant is totally different. So this is called design freedom. You are not forced to use what is available. Some doctor wanted different kind of solution. He was given that kind of solution. But another doctor had different concept in his mind. Similar kind of situation, multiple solutions are available. So in this one, this was a permanent kind of implant. So once implant will remain lifelong with the patient. So this was done during surgery. So this was maxima case in Indian history of orthopedics. अभी तक क्या था, यू सी ऑल केस ऑफ मैक्सिलोफेशियल फेस का था ना. दिस ऑर्थोपेडिक्स, यहाँ से नीचे ऑर्थोपेडिक शुरू होता है. ठीक है. अभी आपने कप देखा होगा, हिप कप का इम्प्लांट बहुत बार आया है. सो हमारे पास वी हैड ए केस ऑफ एम्स दिल्ली जहाँ पे वी वांटेड कस्टमाइज इम्प्लांट फॉर द पेशेंट. जब हमारे पास स्कैन डेटा आया, हमने उसे फेल्ड इम्प्लांट, वी स्टार्टेड रिमूविंग इट. वी गॉट द सिचुएशन लाइक दिस वन. हमारा हेल्दी ऐसा होता है. सो देयर इज नो बोन टू फिक्स दैट काइंड ऑफ इम्प्लांट. अब कैसे फिक्स करोगे? So it was a challenge for us also. उसके बाद we asked for the X-ray. ये मैंने X-ray में देखा तो ये कप जो है पूरा they are floating inside the human bone, human anatomy. So another kind of doctor, what we did is we provide a design customized curve with providing fixation front of the pubic bone and back of the ilium area. तो उससे करके then did all the FEA simulation और पूरा fatigue simulation सब किया because this is load bearing area. Already patient का bone नहीं है, अगर कुछ भी गलत होता है तो again the patient will go bedridden for the rest of his life. This was performed in 2018 for the first one of its kind. So this is another case. इधर क्या था, the patient had a tumor of the acetabulum, this region का. Doctor wanted to use a conventional cup, but because this is a tumor, this has to resect it, cut करना था. If this is cut, the cup won't fix. So what we did, we designed a support kind of implant for this area. इसके आगे वो cup लगा और वो patient पे implant हुआ. So this is a video of the patient. Normally I get only X-rays or CTs of the patient. So this is the luckily I had this video. So you cannot find out whether she is having any kind of implant or not. And all these cases that we did free of cost to a poor patient. So the helmet kind of thing, the implant, if commercially manufactured, won't cost less than 2 or 3 lakhs of rupees, which can be avoided just by using a good quality helmet. So always wear a helmet. And whatever the technology progresses, we cannot replace God, we cannot become gods. The only thing is preserve what God has given you. So again, so this was like social impact, but as a CSR, we must support the industry. We cannot mass produce it. So whatever we have done, we have transferred to industry. We have transferred the customized implant technology to Forbes Group, then spinal implant technology PLIF and TLIF to the UPS Lakshmi, and all the other technologies, the hip and spinal or AVN transferred JK Group company, JK Digital. So this is the infrastructure that we have in CSA. We have a metal 3D printer which we use for titanium printing. Then we have FDM printer, then resin printer. We also have a bio printer with us, whose photo somehow I missed. So these are efforts for like Make India, Swachh Bharat and Skill India. So any questions are most welcome. Or there are no questions.
How do you avoid buckling in your bone and
We provide a safety factor. Also, whenever we do, so we follow a particular standard. So for any hip implant or a spinal or a knee implant, a particular standards, we need to follow that standard only. If it passes that standard only, then we manufacture it. So we do.
about the that is like this, and you have some component that is facing in a position over there.
Actually, what happens is ISO 7006. So angle is placed on the femur head at a particular angle. The compression plate is there. Then the fatigue cycle starts. So typically for a hip implant, it's 5 kN, 5 million cycle. If it passes it, below stamp is held in a bone cement, in a circular cylinder. So it passes. Like every, if you look at a spinal implant, the special fixture was there. So every implant has got its own fixture requirement, load requirements. So it has to pass through those standards only.
One more question is that while talking about hip porous structures, how do you balance this crack propagation? If we have, I think that most of the structures are porous, okay, and they have stress concentration variation, proper stress concentration. Suppose that we have a standard pattern 2D and 3D for metal and 3D for focus components. When this crack propagation is not
So yeah. So when we're designing implant, if it cracks, it's a failed implant. We need to again redesign it. So our implant is designed like that. It should not crack another load applied. So we take care of that. So none of our implants crack at the load requirement. That for spine it is 3 kN. None of the implants. If it cracks, we have to redesign it. It should not crack under loading condition. We have to take care of that. If it cracks, it's a failed implant. We cannot use it.
one thing is that we generally assume that our structures are type of structural holes.
No, these are not. None of them were circular. So they were like you can say Voronoi or gyroid kind of structure. Circularity, we are limiting the surface area which is available for bone growth. So normally, none of them are circular structures. Circular are the basic structures, and those are closed. Like if simple way of designing a circular structure, you take a cylinder, put a hole inside it, but this is a closed structure, so the bone will not connect in between. So it will pass through that. So those kind of structures are not good for orthopedic. Maybe some for other application, but not because we want the bone to grow in between, have a connecting path. Yeah.
So you design so many implants suiting to the specific requirements of the patient. So once you design the implant, then you subject them to in vivo studies also, characterizations or
Actually, what has happened is it is not we when we talk about two different kind of implants. One was generic implants, which are available like hip or spinal implants. There are available multiple sizes. We talk about PLIF implants. Total number of size variation around 134 size variations are there. For TLIF around 234 size variations are. So for what these cannot be implanted in patient as such. So lot of like we did animal studies, the biocompatibility studies, then mechanical studies. Only after that the industry to which we have transferred will get a CDSO license. So now they have got a test license for manufacturing. By the time August end, we are expecting a commercial manufacturing license will come. So only after that we can implant it to patients. A lot of these studies are required. But if we talk about the customized implant, remember these implants are manufactured for only one patient. So what we did is we had a biocompatibility animal testing data of the implant, the powder material which we have mentioned. We don't change the powder material from, we don't use from any other manufacturer. We keep it constant. We keep the parameter constant. But we cannot do mechanical testing. It's not possible to do the biochemical test for every implant. So the basic testing we have done, and we do all the fatigue simulation, FEA simulation. So we have to rely on that. And what the doctor does is, because they have given exemption in MDR, CDSO give exemption for customized implant. So we have designed an implant as per the doctor requirement. Doctor will give a certificate. Okay, this implant designed under my guidance, introduced only one particular patient named this. Only then he will implant. Otherwise, unless until he gives the certificate, we won't give that implant to the doctor for any implantation. That is the mandatory requirement. And because it is only one piece, you cannot do mechanical testing. So you have to rely on the previous data of the biocompatibility and the FEA simulation data only.
so now we have some more Indian companies
Yeah,
manufacturing.
JK, the JK group, which we know about JK Tire and JK Papers, so they are venturing to medical. So they will be soon getting the manufacturing license for spinal implant and the augments and the astral cup and the cone cup. Yeah. So the avian implant was taken by Cipla. So Cipla initially wanted to venture into orthopedics, but their plans are like still not finalized. It may take more time. But the JK group, the spine, all other implants, apart from the avian implant, will be available in the market by the time of October or November to patients. So at a comparatively easier cost. Like the spinal implants are not available, like porostructure structure not available in India, and the other implants, hip, are at very exorbitant cost. So even a person like us, it is not easy for anyone to afford a 1 lakh kind of implant. So because of they were forced to use a substandard kind of treatment. So this we wanted to avoid. Yeah. Thank you. So I hope it's done. So thank you. Yeah. Any question was there?
Thank you so much, sir. It's my privilege to introduce our next esteemed speaker for today, Dr. Sachin Tyagi, sir. Dr. Tyagi is Scientist Head and Head of Advanced Engineering and Design Department at CSIR CSIO, Chandigarh. He is an accomplished researcher with expertise in advanced materials, nanoscience, and engineering design, with over 180 research publications, numerous invited talks, and prestigious recognitions, including the CSIR Raman Research Fellowship. Dr. Tyagi has made remarkable contributions to research and innovation. His work has been supported by leading organizations such as DRDO, CSIR, and DSE. Everyone, please join me with a huge round of applause to extend a warm welcome to Dr. Satish Tyagi.
Good afternoon, everyone. So I can understand since morning you all are sitting here and only 20 minutes are left for lunch. So it is going to be very difficult for all of you to listen me because in your age when I was doing my graduation and someone is coming to our institute giving presentation and even if any PhD student is also there. So that time I used to think like what these people are doing here. They are boring me. I don't know why these people are working so much, why they are having so many presentations. But after some time, I realize I was wrong, because when we are going to face the truth of life, then we all have to do the same thing in future. So today I will not take much time, but I will try to make you familiar with something, so that for whole of your life, if you will listen anything related to my today's PPT, you can easily connect. Okay, I know this. So first of all, I would like to introduce myself. I am Dr. Sachin Tyagi. I am working as a scientist at CSIR CSIO Chandigarh. So what is CSIR? CSIR is a Council of Scientific Industrial Research. It comes under Ministry of Science and Technology. So we are 37 labs all around the India, and out of 37 labs, there is a lab in Chandigarh, that is Central Scientific Instruments Organization. The mandate of this lab is to design and develop the various instruments for defense as well as for the industrial application. So this CSIR lab consists of the following departments, where we are working for the agriculture based electronics. We are developing instruments for the biomedical sector. We are developing instruments for the aerospace industry. Almost all the cockpit instrumentation at present in all the fighter aircraft is being developed at CSIO Chandigarh only. We are working in the optics based sensors, and large number of instruments we have already developed and installed in Pan India. So actually, one more thing I want to tell you here, I am a material scientist. I am not a mechanical engineer, but the purpose of giving presentation today here, we don't need to have a basic degree in a particular area to do something, because today's world is an interdisciplinary world. So as a material scientist, when I started my career, with the time, when I realized, okay, I am developing material, but this material is having no use. I am just getting publication, I am doing patent, getting my promotion on time, and wasting the time of whole country. Because it is going to be beneficial for me only, not for the nation. But as we are working in the R&D lab, so our main mandate is to do something that can be used for the society as well as for the country. So then I realized, okay, we should go for the development of the products. So here I will tell you a very little bit story in within 15 minutes, how a material scientist can go for the development of design, and those design can be used for the defense application. So here I will talk about the stealth application. You must have heard the word stealth. Stealth word came from the word steal. Steal means hiding something. So we also want to hide something from our parents when we are making any mistake. In the similar way, for the defense sector, in the Operation Sindoor, you must have seen that we are having a very strong radar system, from where we are getting the information about the drones coming from the enemy countries. In the similar way, all the countries have their own radar system. So they also want to detect your metallic articles. But the way you can enter into their country without getting any harm, you need to have something by which you can hide yourself. So that comes under the category of the stealth technology. So stealth means you want to hide some metallic article. That metallic article can be your aircraft, can be your tank, can be your missile, can be your drone. So stealth means hiding that metallic article. So when we talk about the hiding starting from the visible vision, like you can see something. So this is also part of hiding. Second way, suppose you are having something which is radiating some radiations, then we have very high grade thermal cameras. They can detect even in the night. And the last powerful tool is the radar. Radar has some microwaves. These microwaves get reflected by these metallic articles, and these microwaves can easily detect. So now you have to protect yourself from three things. One is the visible, second is IR, third is microwave. And when you have something which can hide all, then you can claim that my material is a stealth material, or my article is now a stealthy articles. So here, what terminology we generally use to make a system stealthy? We need to have something that can be coated over the surface, or we need to have something that can be shaped in such a way, like if suppose some radar is coming from this direction, we can reflect this radar into the direction other than the direction of the detector. So there are 2-3 ways by which you can make a article, a stealthy article. So what measurement we generally do to detect something? That is the RCS, radar cross section. So lesser is the RCS, lesser will be the detectability of your material. So here we are going to measure the RCS. If your RCS value is minus 10 dB, then it means you are absorbing almost 90% of the radar. If it is more than 20 dB, you are absorbing 99.9% of the radar. Absorbing means it is not going to get reflect back to the detector. So this is the whole principle behind the stealth technology. So as I told you, we have 2-3 technique. This is the example of shaping technique in which we shape the aircraft in such a way like it can reflect the radar in the direction other than the direction of the detector. So these are the two examples, one FA-17 Nightwalk stealth fighter aircraft and second one is the B-2 bomber. So this is the basic setup where we can measure this kind of stealth features. This is a RCS measurement setup. This is RF anechoic chamber basically. This kind of chamber you have seen in the acoustic form, like the recording studios, they have this kind of chamber where we used to have recording. That is an acoustic chamber. But this is not an acoustic chamber, it is a RF anechoic chamber. RF anechoic chamber means at present today, whatever the electronic component or medical instruments we are developing, any instrument, if you really want to get it into the market, then that instrument should have EMI EMC test, electromagnetic interference and electromagnetic compatibility test. So that test should be done in an area where you don't have any reflection from the walls. So that kind of reflections can be avoided by covering those walls with some material that can absorb those kind of microwaves. So that chamber which is I am talking about here is called RF anechoic chamber. The cost of one RF anechoic chamber is 22 CR, and at present no one is developing this kind of chambers in India. But in CSIO we have developed these foams, and now a company based in Mohali, they have developed their own RF anechoic chamber in the cost of 2 CR only. So this is, I am going to tell you how a material can be converted into a product, and that product can be utilized by the society as well as with the industries. So this is the setup. As I told you, when you want to hide something, it should be not detected by, it should not be detected by visible region. It should not be detected by NIR, IR region or microwave. So for visibility, we have camouflage technique. Camouflage means you wear a kind of cloth which is resembling with the you can say surroundings. Suppose you are in an area where snow is there, then you need to have some white colored dress. If you are in an area where some sand is there, you need to have dress resembling with the color of the sand. This kind of technique is called camouflage technique. Second one is the, as I told you, some radiations will be emitted out. So you can hide those radiations by having low emissivity coatings or low emissivity paint. And third one is the microwave. So when we talk about the microwave have frequency from 1 to 300 gigahertz, but for the military band we have only one frequency band, that is the X band, 8 to 12 gigahertz. So these are the various bands which we generally use for the detection of the metallic articles, especially for the stealth characteristics. So now when we talk about the development of any material that can be applied on some metallic article to make it stealthy, we have plenty of material. Why we'll have to have plenty of material? Because as you know, DNA is there. DNA, you know DNA, हर एक का DNA अलग होता है. Suppose if you are saying this has not been done by me, or it is not my blood, or whatever the symptoms you are getting here, it is not resembling with me, it is not with me, then we have DNA test. So everyone has its own DNA characteristics. In the similar way, all material have their own characteristic wavelength. So every material has its own characteristic wavelength. So wavelength is a very important criteria by which you can identify any particular material. So in the similar way, this characteristic wavelength has a particular frequency, and every material has its own resonating frequency. So if you are going to use any one material, then you can have these reflection loss, you can say, but at a particular frequency. But if you really want to make a stealthy article, then it should have the absorption for whole band. Whole band means, suppose I am talking about 8 to 12 gigahertz, so it should not be like 8.2 gigahertz pe absorption aa raha hai, baki pe nahi aa raha. It should have absorption for whole band from 8 to 12. It should have 10 dB bandwidth for whole band. So in that case, if you want to get this kind of material, you need to have a plenty of material, because you have to optimize the composition, you have to design the composition. So that is why we have different materials. So here first material is dielectric material, it imparts the dielectric loss. Second one is magnetic material, it imparts the magnetic losses. Conducting material, scattering material, metamaterial. So in this, in today's presentation, I will highlight on the metamaterial, but before that, I will give you a glimpse of work, what we have done in the material science. So first we have developed the material by top-down approach or bottom-up approach. Top-down means you crush the particle, take it to the nano size range. Bottom-up means you precipitate the particle. बॉटम अप इज नथिंग, आपने दूध जैसे हम दूध में हम थोड़ा सा लेमन डालते हैं तो मिल्क में प्रेसिपिटेशन आ जाता है और वो बाद में पनीर बन जाता है. तो दोज प्रेसिपिटेट आर नथिंग बट द नैनो पार्टिकल्स. सो इन द सिमिलर वे वी हैव वन प्रेसिपिटेटिंग एजेंट, we precipitate the solvent and we get some nanoparticles. So we have two approaches, but the advantage of first approach is this is ball mill setup, because in the second approach where you are having precipitating particles, so in that case your production will be very less. In milligram and gram you will get the particle, but if you want to use this material for bulk, then you need to have something in kgs and tons. So this approach is good for those in which we want to develop the material in bulk. So we are adopting this technology for developing the material for stealth application. So I am not going to discuss all those things because these are related to material science only, but when you develop any material you need to characterize the material. So we used to do the XRD of the material, like whatever the material I am claiming, it is in pure form or not. Suppose I am saying it is a zinc oxide, maybe it is a magnesium oxide, then how will you make me clear? Then we need to have XRD. How the particles are looking, this is electron microscopy image. The particle size is in micron size range, which cannot be seen by the naked eyes. So these are the particle shapes. This is the thermal analysis. When my material will be heated, how it will behave. And this last one is the reflection loss parameter. As I told you, we need to have something which has absorption more than minus 10 dB. But here absorption is very good, but it is at a particular frequency, not for the whole band. So if you are doing this kind of work, you can get one publication only, nothing else, because you need to have something which can have complete minus 10 dB bandwidth, because X band is a military band. So they will detect you using the X band frequency only. Suppose you are getting 10.1 gigahertz resonance, then you will not be detected at 10.1 only, but at the other frequencies you will be get detected. So here I will tell you how we have made a composite material in which we have made a minus 10 dB bandwidth composite. Then we switched to two materials, ferrite and CNT, carbon nanotubes. We made the composite and we got, see, minus 42 dB I am getting. Minus 42 dB means 99.999% absorption, but at particular frequency only. Then we made another composite, RGO, reduced graphene oxide. Again we got very good result, more than minus 50 dB. More than minus 50 dB means again 99.999, increase the significant figure only, but bandwidth is not very good. Then we moved to a novel composition. Then we contacted to some industries working in India. They are developing their indigenous material, but they were working for transformer core. So what we have done, we have taken their transformer core, we crushed their core into the powder form, and then we made some absorbers like foam. These are the RF anechoic chamber forms that I showed you in my RF anechoic chamber slide, and these are very flexible form, and this is minus 10 dB bandwidth for whole X band. And this material we developed from the industrial powder only. If you will tell me, okay, I need one truck material, I can give you. But if we will develop this material in lab, then we can't give this material in, we can give this material only in grams or maximum 1 kg. But for that, my student will have to work for 1 year, day night in lab. Then only he can get 1 kg, and again repeatability issue will be there. So repeatability is a very big challenge in material science. Every time you will get different. So better you work with industry, because industry have their own standard. They have already qualified some standards, so they can give you material in a repeatable form. So we have made this kind of composition from the industry powder only. And this is a flexible form. So there was a word that I heard 3 years back, wearable stealth features. Means Now I want to have a jacket, I want to have a shirt, or I want to have a I can say tripal kind of thing in which I can hide something metallic article. That can be a weapon, that can be a tank, that can be something which is metallic in nature, and we want to keep it for 2 or 3 years safely, and so that it cannot be detected by the satellites or by the radar. So in that case, this kind of foam material can be used. So this is called wearable stealth. Now, this is the RF anechoic chamber. So this is the chamber one industry made at Mohali. So this chamber is not only being developed by a material scientist. Here we need to have a group of scientists, one which is having a experience of mechanical engineering, because here we need to shield this whole chamber using metallic sheets, and we need to have electronics engineer that can put some transmitting antenna, receiving antenna, reflectors, and last one is the material scientist who can cover these walls using these foam absorbers. So these absorbers we developed at CSI. Here shape is also very important. So we have simulated the shape also. We have designed the shape, starting from designing the material, starting from designing the composition. Then we went to the designing of the form, shape, and then finally we obtained this kind of absorbers. So designing is not only to do something at software, give this design for the fabrication to a 3D printer engineer, and that will make. Sometime we need to play with the material also, because suppose you are getting something that can be used for the nation, but you are taking this material from abroad, and when you really need this material in bulk, maybe something will happen and supply from the abroad will be stopped, then your whole technology will be useless. So if you really want to develop something indigenously, these days we are talking about indigenous. Everywhere you are hearing the word indigenous. So indigenous is not like that you are developing something on computer getting fabricated. Indigenous means we have plenty of raw material in our country, but still we are looking for the same raw material from abroad. So we should stop that. So how we can stop that? When we will go with, when we will hand holding with our own industries, we will see what powder they are having, for which purpose they are having, what powder is having the characteristics, can I convert this powder into some other application. So then only after 2 or 3 years you can reach a place where you can say that, okay, starting from material to design to product, the whole thing is designed by me only. Then you can say that this product is a completely indigenous product. So this we have done. I am skipping this. Now metamaterial. So this is totally design thing. So what is metamaterial? You know, when we are in 10th standard, we heard about refractive index mu equal to C upon V. C can never be less than V. So mu cannot be negative. But mu can be negative. Because the natural material have some limitations. They can't give you some properties which is almost impossible for the conventional material. But there is a technique in which you can make some designs. That design is called unit cell, and those unit cell can give you those kind of property which can not be achieved in conventional material. So those designs, those engineered array of structure is called metamaterial. So metamaterial is nothing but the engineered unit cell array which can manipulate the property of the material by interacting with the electromagnetic waves. You can get negative refractive index, you can get negative permittivity, negative permeability, even you can become invisible also. You know the impedance of air is 377 ohm. If you can design something which can have impedance of 377 ohm, then you will become invisible. Because when your impedance will match with the impedance of air, you will become invisible to that EM wave. In the similar way, when your refractive index become equal to the refractive index of air, you will become invisible to the visible region. So by having this kind of metamaterial structures, you can manipulate the properties. So this kind of work we are just doing at CSIR. So we are developing this kind of metamaterials. As I told you, they have 3 mechanisms. One is impedance matching. You match the impedance with the impedance of air. You have ohmic losses, means your EM wave interact with the unit cell, and those interaction will give you the loss of energy. in terms of ohmic loss, conducting loss, and third one is the multiple internal reflection. It is a kind of the mechanism where once the wave enter into the structure, it will get reflected within the structure, it will not come out, and my target is to lose the energy so that it cannot come out. If it is coming out, it should not be that much strengthened, like it should reach to the detector. So these are the different mechanisms. So we have made these kind of structures. First we have designed the structure using ANSYS HFSS software. This is called simulation, and first we simulate this. And important thing is that whatever we are using here is indigenous. Whatever the form we are using here is indigenous form, we are developing that form. Whatever the material we are using is indigenous, that is the material we are developing in the lab. So this is the unit cell structure we developed, and now this is the simulated data. Minus 10 dB bandwidth we are getting from 4 to 14 gigahertz. Now next part is go for the fabrication. So here we are fabricating it by using very simple 3D printer, FDM, and sometime we are using screen printing also. Okay, so we are developing these kind of structures there. We have developed different designs. We are giving more than minus 10 dB bandwidth. As I told you, minus 10 dB means 90% absorption. So this is the array of unit cell we developed by using AutoCAD. This is a screen printing technique. We are printing these unit cell structures, but कोई हाई-फाई साइंस नहीं है, घर में भी कर सकते हैं आप. ये सब हमने खुद फैब्रिकेट किया है. स्क्रीन प्रिंटिंग सेटअप खुद बना लिया, इंक हमने अपने मटेरियल से बना ली, सब कुछ खुद ही किया. So these are the different unit cells. This is flexible. Again, this is a flexible metamaterial. Because form is flexible, that structure is flexible, so it can be used for the variable stealth application. So these are our product. You can have transparent metamaterial also. This is also having stealth feature that can be used for the canopy application. You have variable stealth. As I told you, this is the fabric having the characteristics of microwave absorption. These are the other products: RAM coated sheet, microwave absorbing foam, microwave absorbing tiles we are developing, minus 10 dB bandwidth for whole X band. This is the industry project that we have completed. So, yes, as I was heading a department where we were working for the cockpit instrumentation. So at present, almost all the lights related to this fighter aircraft are being developed at CSIU only. And one of our scientists, he is working on the design and development of the electrostatic nozzle. By using that nozzle, he is using that particular nozzle for the different application for aerial electrostatic spring that can settle the PM 2.5, PM 10 particles. He is using that nozzle for spraying the pesticides over the crops, because there is a phenomenon of, you can say, electrostatic charging, by which the wastage of material will be very less. Your whole medicine will go to the plant only, it will not go to the ground. Jai Hind.
Thank you, sir, for your enlightening session to give insight on metamaterial. Now we have lunch break from 1 p.m. to 2 p.m. Hands-on session will start from 2 p.m. and don't forget to bring your laptops for practical session. Thank you. If you have any question answer, you can ask.
Yes, please. That can be done, but when it is in at a particular height, you cannot see that. But वो कर सकते हो, पेंट ही हो तो that is only a paint. तो जो sky color.
We have seen they made paintings.
ये करते हैं लोग.
to distract them, but come off stage by just making some tiles that can change their color or something according to the
जैसे लाइट की प्रेजेंस में कलर चेंज होता है. Active material.
like we have seen the movie Spider-Man. They were come out stage like building if the stage went to the build according to that, and then it went
We will now proceed for lunch.